Hey guys, today we are taking notes for transformations of functions. If you go in Google Classroom, then you can see the sheet I'm writing on, or you can feel free to do this on a piece of paper of your own. So at the top here, this y equals negative a parentheses x minus h squared plus k. This is we're just doing all the notes with a quadratic, but you can do transformations on any function. You can do it on linear, on cubic, on radical, but I'm going to give you the notes using quadratic. So that's why I have drawn a quadratic function here. And I've drawn the parent function, which means the most simplest form one, where the vertex is at the origin. The origin's the center here. So I just want to tell you what each of these pieces does to move the function. This negative here in front, it reflects it over the x-axis. So if I have this original function here, it's going to flip it so that it looks like this. So anytime you see a negative in front, that function has been flipped. The A has two parts, so I split them. There are two. One of them is called a vertical compression. And the vertical compression makes the graph wider. So this is when A is between 0 and 1. So pretty much if it is a fraction less than 1, it's going to make the graph wider. So the new one would look like this. See how that's wider? And then we have the second one, which is a vertical stretch. This is if A is greater than 1, and it makes the graph skinnier. So it would look like this. So one makes it wider, and one makes it skinnier. The H is a horizontal shift. And it moves the graph left and right. Just as a side note, I do need you to know that right is negative and left is positive. Which means if you see H and H is negative, it's going to move right. And if H is positive, it's going to move left. So just so you know. But we'll talk about this more in class. So an example of this would be if this moved right 3, moves your graph left and right. And then the last one is a vertical shift. This is K. This moves the graph up and down. And up is positive, and down is negative. So if I take this graph and move it down, it actually looks like this. Okay? So these are all the transformations that can happen on a graph. Like I said, I only did the quadratic, but we can do these for any function. So we're going to go through a few examples real quick. So it says, write the equation of an absolute value function that has been vertically stretched, reflected over the x-axis, and shifted 8 units down. So if I'm going to write an absolute value function, I have y equals, there's going to be absolute value bars. So if it is reflected over the x-axis, that means there's a negative out here. If it gets stretched, that's this one, that means A needs to be greater than 1. Any number will do. I'm just going to use 2. And then it went 8 units down. So K is the, oops, sorry. K is the one that moves up and down. This is outside. So the absolute value of X, it went down, so that's going to make it -8. So that's how you would get that from this. We're going to skip this one for now. On the second page, it does show you different functions. So over here are your parent functions. So if you want to write that. Remember, a parent function is a function in its simplest form. So exponential is 2 to the x power. We have absolute value of x, 1 over x, square root x, x squared. Others are x cubed, x to the 4th. We went over all of these in your types of functions notes. So for these, it wants me to match the function to the parent first. So let's do that first. I'm actually going to zoom out a bit so you can see it better. Okay, and I'll change the color too. So exponential, that one is here. I have 2 to the x, and this became 2 to the x minus 4 plus 1. So what happened? What transformations do I have? Well, the x minus 4 is inside the exponent, so anytime something happens inside, that is where h is. So this moves left and right. It's a -4, which means it moved right 4. And then the plus 1 on the outside, that's the k, so it went up 1. So those are those transformations. For absolute value, that one is here. So I have the absolute value of x. It got translated to be negative absolute value of x plus 5. So the negative reflected it over the x-axis. And this plus 5 on the end made it go up 5. So let me refer back to the notes real quick just to show you something. Whenever I'm talking about inside and outside, I consider h my inside number. So I'll put that here. Okay, that's this one. The reason I call it my inside number is because it's inside the parentheses, or it's inside the exponent, or it's inside the square root, or it's inside the absolute value bars. It is inside of whatever we got going on. K, this is what I consider the outside number, because it is outside the parentheses, outside the absolute value bars, outside the exponent, outside of the radical. Whatever you're dealing with, K is always on the outside, and H is always on the inside. So maybe you want to add those real quick. That way when I talk about them, you know what I mean. So here, 5 is outside of the absolute value bars, so it goes up and down. It's positive, so it went up. Here, 1 is outside of the exponent, so it went up. But 4 was inside the exponent, so it goes left and right. Next we have rational. Rational goes here. So 1 over x turned into 1 over x plus 4. Now, the only thing different is this plus 4, and the plus 4 is inside the denominator. So if it's inside, that moves it left and right. So this one went left 4. Next is square root. So square root of x turned into 1/3 square root of x minus 1. So this 1/3 is between 0 and 1, which means this is a vertical compression. Of 1/3. This minus 1 is inside the radical. So if it is inside, that means it goes left and right. Negative goes right. So this went right 1. And then the last one is quadratic. So x squared turned into 2x plus 3 squared minus 1. So the transformations here, the 2 in front is greater than 1. This is a vertical stretch of 2. Always tell me what the stretch or compression's by. So this is up 2, up 1. And same thing when you move like left and right. Tell me how far you went. So right 4, up 1. And then we have a +3 on the inside. That means it went left 3. And we have a -1 on the outside. That went down 1. So we're going to do some more practice with this in class. I just wanted to give you the notes and give you a few examples. See you guys later.